So in the second presentation we are going to discuss one of the ancient Indian nanomedicine which is known as Bhasma, and this presentation is going to give you few insights about the advanced chemical knowledge of our ancestors. We are saying that they were using the advanced scientific knowledge, so in terms of science, how it is comparable to the modern science. Basically they were using metals and minerals as medicine, and it is already mentioned in the old text जिसको हम लोग जानते हैं कि चरक संहिता और सुश्रुत संहिता में ये चीज़ें ऑलरेडी मेंशन हैं. Normally these two were written around the 3rd century before Christ. So आज से लगभग 3000 साल पहले ये बुक्स लिखी गई हैं, and the doctors of that period, which were known as Vaidyas, discovered that if metals like gold, copper, silver, mica were carefully purified and heated in a specific way, they could be turned into the fine ashes, and they are called as Bhasma. They believe that if these ashes are used properly, they may balance the body, remove harmful substances, and cure many diseases. So I have made this cartoon that how the traditional knowledge is comparable to the modern nanoparticle synthesis. But before start, we should know the time chronology which I was discussing in the previous lecture, that initially the era of Mohenjo-daro or Harappa was started around 3500 BC to 1750 BC, and after that the pre-Vedic era and then Vedic era was there. So the period of Vedic era was in between 1500 BC to 500 BC. So the concept of Bhasma or metal nanomedicine was started approximately 4,000-5,000 years ago, and at that time there was no availability of any advanced machines. So what they did, they make metal based bhasmas which were natural nanoparticles, and similar to the modern nanoparticles, they have high surface area to volume ratio, enhanced bioavailability, and better cellular absorption due to their size. They discovered all the aspect of bhasma, that these bhasma special ashes substances which are generally made by heating metals, minerals, and some herb substances, and the process includes purification, calcination, and mixing with different herbs and some of the quenching agents. And all these materials which they were using were claimed to be safe, effective, and used to treat for many chronic health conditions. The process of making bhasma involves, if we will discuss step by step, it involves removing harmful substances, changing physical properties, and increasing medicinal effectiveness. The approach which they used traditionally are believed to help balance body functions, eliminate toxins, and protect against disease. Of course, with the time the making of these bhasma were found more detailed, because the skilled practitioners, the Vaidyas जो उस समय वैद्य थे उस पीरियड के, they learned, they practiced to heat these metal repetitively in controlled way, often used fire and herbal liquids to make them safer and finer. और ये जो प्रोसेस था इसको जो बर्निंग का स्लो बर्निंग का प्रोसेस था उसको पुता कहा जाता था। और इस पुता के प्रोसेस को कई बार रिपीट किया जाता था, तब वो पार्टिकल नैनो फॉर्म में जाते थे। तो इन्हीं प्रोसेस को हम थोड़ा सा डिटेल में पढ़ेंगे। और डिटेल में पढ़ने से पहले कि हाउ they are comparable to the modern techniques or modern nanoparticles. So in modern scenario, generally we used to study different type of nanoparticles, like carbon nanoparticles, spherical nanoparticle, quantum dots, liposomes, dendrimers, of course SPIO, which are iron oxide nanoparticles. And generally the techniques which we are using, they are for morphology and for their shape and size, that are TEM and SEM. Their diffraction pattern based on XRD diffraction, particle size analyzer, their zeta potential, and FTI. In addition to that, FTIR and UV gives about the information of these particles. But once we back, in ancient period, at that time there was no availability of these machines. In modern time we have all the machines like TEM, SEM, XRD. So if a person is preparing this in a lab, so he will go to the lab and will check what is the potential, what is the size distribution, what is the morphology. But no, traditionally it was not available at 5,000 years ago. So what they were doing in the Vedic period, they were using few of the process in which some of the substances which were herbal in the nature, they were taking it, mixing it, quenching it, and finally doing calcination in mild heat system. So step by step, if you will see the process, the first process was sodhana. The two main process for this bhasma preparation was sodhana and marana. So sodhana means you are mixing and then adding with some substance, and in marana, mild heating. So sodhana was basically thermal treatment, oil quenching reaction, and photochemical interaction, and marana was complete chemical formation with respect to their nano size. So if you will see the sodhana process, it has 3 steps. In general, normally you feel that once the metal is heated, it comes in sodhana, but no, it comes 3 process. First, you will heat the metal at a particular temperature. So by this way, what you are doing, you are changing the metal into metal oxide, and then you are going to mix it with some of the oil or some of the natural substance in which it can be dissolved, and then you are giving the thermal shock to its one. So sodhana means the first one is heat treatment, normally at high temperature. It means the temperature at which metal is going to be melt out. And then in the second step, you are using quenching. Now the metal is about to melt out, or red hot metal is near to its boiling point. You are plunging it, you are mixing it into liquid media. And what are the liquid media which were used at that time? Like sesame oil, cow urine, herbal materials, buttermilk, kanji, and radish extract. So these are the materials which were used for quenching, and you will see that all these materials are biocompatible. None of the hazardous chemical was used. Now this heating and quenching process was repeated with fresh liquid many times. sometimes 7 times, sometimes 20 times, sometimes 50 times. And the purpose of this repetitive process is to reduce the toxicity and change the outer orientation of that metal. So what is the chemistry which is involved in this one? You are changing the metal surface. Metal surface is going to be oxidized because you are using high temperature. I mean, if you are heating, of course the surface area is going to be increased. You are doing this process at high temperature, so the impure things are going to be separated out. Similarly, the crystal structure, I mean, it is going to change from metal to metal oxide. So definitely some defects will be there, some morphology of the metal will be changed. So you are changing the crystal structure modification. And finally, yes, the nature of that one is be fragile in the nature, because I mean it should be like dust particle, it should be like चूरन जो हम कहते हैं उसकी तरह से बनना चाहिए. सो अल्टीमेटली इसकी मार्फोलॉजी में क्रिस्टलिनिटी का लॉस हो रहा है. तो ये तो फर्स्ट स्टेप था जिसको हम शोधना कहते हैं. दूसरा स्टेप होता है माराना और जराना. सिंपली मराना या जराना. इसका मतलब ये है कि अब आप इसको हीट करने जा रहे हैं. बट हीट का मतलब यू आर गोइंग टू डू इट gradually, or you need some juices, you need some herbal substances. So what herbal substances they have used? Aloe vera, trifla, different plant juice, and after that you are going to make it as a pellet, then going to use it in a crucible, and then you are providing mild heat as the previous picture was showing. So these two steps are the major steps for the formation of the Bhasma particle. The last step in which you are using the puta, you are doing the repetitive process. So initially you did metal to metal oxide, and after that you used some of the natural material like cow dung to provide the reducing atmosphere. What it will do, due to this reducing atmosphere, your metal oxide is going to carbonized in nanoparticle formulation. And what is going to happen? For example, it is going to change iron to iron oxide, copper to copper oxide, zinc to zinc oxide, lead to lead oxide, and subsequently their carbonization. Once it is carbonized, how the quality test will be analyzed? As I say, you are not going to use metal as a medicine, nanomedicine. It should be just like powder. So it should be luster free, there should be no sign, there should be no metallic character. So all that can be quality controlled or assessed by different tests which are given here, and I have already discussed with you in our lecture also. So chemically, what are the changes which is very important for this process? That one, phase change. Initially it was metallic in the nature, but at the end or at the nano formulation time it is oxide, which is amorphous in the nature. What you are doing, the particle engineering, or in sense of the particle formation, you are taking the approach of mechanical, thermal and chemical reductions. You are using phytochemicals like juices and other which are acting as a capping agent. And for safety, for reduced toxicity, you are doing the putas process in many steps because it will reduce the toxicity. So I will give one by one example, like sodhana. The first process is sodhana, means purification. And how you are purifying it? By soaking and boiling. What will happen? Impurity will remove and color will be changed. The next is marana or jarana process, which is known as calcination. So what you are doing in this process? Repeated mild heating and grinding in many cycles. So in ancient time they were using different furnace, different setup, and they were changing metal to metal oxide in mild heating process. The other process, under the marna, the next is bhavana, trituration. What you are doing? You are grinding it with herbal juices, or you are incorporating the biological capping agent to make it more biocompatible and safe for human and animal application. Next one is chakrika. So in chakrika you're making it, the pallet formation, you are doing it in pallet formation. Next is sarava samput. This is the fifth step. So in sarava samput, what you are doing? You are making is clay sealing through clay sealing and putta. It's a heating cycle which you are using it many cycle. Mild heat, medium heat, intense heat, mild heat, medium heat, intense heat, with the help of cow dung cake, जिसको हम लोग गाँव की भाषा में कभी कभार उपला गोईठा ये सब बोलते हैं. तो उन्होंने क्या किया कि उपले या गोईठे की सहायता से उसकी हीटिंग को बार बार कंप्लीट किया. तो अगर हम इसके डिटेल की बात करें तो कहेंगे कि विथ द एडवांसमेंट इन वैदिक इरा, मीन्स फ्रॉम पोस्ट प्री वैदिक इरा टू पोस्ट वैदिक इरा, इनके जो मेथड्स थे उनमें भी बहुत विचार बहुत चेंज आया. चेंज किस सेंस में आया? जैसे कंट्रोल्ड हीटिंग कर रहे थे वो, तो जो कंट्रोल्ड हीटिंग का मेथड था इसमें बहुत बार बदलाव किया गया. जो वो हर्बल मटेरियल ले रहे थे इसमें भी काफ़ी इम्प्रूव किया उन्होंने. हर्बल मटेरियल को मैंने कहा कि ये एक एज अ कैपिंग एजेंट यूज हो रहा है, तो उसका पर्पज हुआ कि अच्छा मटेरियल सेफ बन सके. कैपिंग एजेंट के कारण आपका मटेरियल सेफ हो जाएगा, क्योंकि मेटल, लार्ज अमाउंट ऑफ मेटल इज़ नॉट गोइंग टू बी वेरी सस्टेनेबल फॉर ह्यूमन बॉडी. व्हाट दे वर यूजिंग? दे वर टेकिंग हर्बल एजेंट या हर्बल लिक्विड और उसके साथ उसको माइल्ड हीटिंग दे रहे थे. तो और उसके बाद क्या कर रहे थे? जो हीटिंग का प्रोसेस था उसको रिपीटेटिवली माइल्ड हीटिंग, लो हीटिंग, हाई हीटिंग, इसको बार बार रिपीटेटिवली कर रहे थे. तो इससे क्या था? जो पार्टिकल था वो नैनो फार्मूलेशन में चेंज मार्फोलॉजी के साथ हो जा रहा था. और वंस दे हैव चेंज इन नैनो फार्मूलेशन या टिनी पार्टिकल में, तो सिंपली बहुत आसानी से बॉडी द्वारा अब वो एब्जॉर्ब किए जा सकते हैं. तो अगर मैं एग्जाम्पल दूँ तो उस समय कुछ मटेरियल जो भस्म की तरह से यूज किए जा रहे थे वो था सिल्वर भस्म, दूसरा आपका स्वर्ण भस्म, तीसरा आपका कॉपर भस्म था जिसको हम ताम्र भस्म भी कहते हैं. तो एक तरह से स्वर्ण, रजत, ताम्र, लौह भस्म, ये चार चीज़ें थी जिसको आज की डेट में मॉडर्न साइंस में कंपेयर भी किया गया है. और ये सभी पार्टिकल आज की डेट के बायोलॉजिकल नैनो पार्टिकल के हिसाब से, जो कि बहुत ही प्रिसाइज वे में बनाए गए हैं, उसके हिसाब से बहुत ही सक्सेसफुली ये पाया गया है ये सभी नैनो पार्टिकल हैं, बायोकम्पैटिबल हैं, डिफरेंट बायोलॉजिकल एप्लीकेशन के लिए यूज किए जा सकते हैं. अब मैंने कहा कि बेसिकली इनका टेक्सचर बदल जाता है, और जो पुताज यानी माइल्ड हीटिंग, मॉडरेट हीटिंग और इंटेंस हीटिंग के फेज होते हैं वो चेंज करने होते हैं। तो जब इसको कंपेयर किया गया मॉडर्न साइंस में, तो स्वर्ण भस्म जो होता है, जो कलर चेंज दिखता है उसमें डार्क ब्राउन टू रेडिश हो जाता है। इनके नैनो पार्टिकल जो ऑक्साइड फॉर्म में बनते हैं वो अप्रॉक्सीमेटली 60 nm के आसपास बनते हैं, और जो पुतास जो हीटिंग का साइकिल है वो 7 to 14 होता है। ताम्र भस्म में ग्रीनिश ब्राउन कलर CuO कंपोजिशन होता है और 12 to 20 साइकिल्स में जाता है। लौ भस्म में 9 to 21 साइकिल में यूज होता है। जिंक भस्म में 21 साइकिल में यूज होता है। और इसी तरह से जितने भी अगर लेड के बनाए गए या इस तरह से बनाए गए, तो उनके जो नंबर हैं, जो यूज के नंबर हैं, जो पुतास के नंबर हैं, वो उनकी टॉक्सिसिटी के बेसिस पे है। जैसे लेड यूज किया गया तो उसको 30 के आसपास साइकिल में यूज किया जाए, जिससे कि उसकी टॉक्सिसिटी कम हो जाए। अब ये सभी पार्टिकल जो भस्म थे वो डिफरेंट यूज में यूज किए गए, डिफरेंट थेरेपेटिक एप्लीकेशन के लिए यूज किए गए। कारण ये था कि ये सभी नैनो पार्टिकल थे और इन द रेंज ऑफ 0 to 100 नैनोमीटर था, इसलिए बॉडी में ईज़िली एब्जॉर्ब हो जाते थे और सेल तक या टिश्यू तक ईज़िली पहुंच जाते थे। ऑफ कोर्स नैनो पार्टिकल होने के कारण इनका सरफेस एरिया बहुत ज़्यादा हो जाता था, इसलिए इनकी एफिकेसी भी अच्छी होती थी। बिसाइड्स दैट ये चूँकि मेटल बेस्ड थे, मेटल ऑक्साइड बेस्ड थे, तो इनमें एंटीऑक्सीडेंट प्रॉपर्टी भी थी। और मतलब बेसिकली जो बॉडी में फ्री रेडिकल्स जनरेट होते हैं जिससे कि सेल्स डिटोरिएट होती हैं, तो फ्री रेडिकल्स को इलेक्ट्रॉन डोनेट कर देते हैं ये नैनो पार्टिकल, जिसके कारण जो सेलुलर फंक्शनिंग डिफॉर्म हो जाती हैं, डिटोरिएट होती हैं, वो स्लो हो जाता है। तो इसलिए भी इनका बहुत अच्छा। इसी तरह से जैसे मान लिए कॉपर है, तो कॉपर का यूज बेसिकली एसिड रिफ्लक्स में या गैस्ट्रोइंटेस्टाइनल में बहुत ज़्यादा किया गया है। इसके अलावा जो मेटल इम्बैलेंसिंग की चीज़ें हैं, मेटल इम्बैलेंसिंग जो मेटल आयंस के थ्रू कंट्रोल होती हैं, उसका भी बहुत ज़्यादा इस्तेमाल किया गया है। तो नॉर्मली ये सब चीज़ें जो है इन भस्मास के थ्रू उनको बहुत पहले से ही पता चल गई थी। और जो चीज़ आज हम शायद 5000 साल बाद पढ़ रहे हैं, वो उस बात की एवरीथिंग, how to make it biocompatible, how to make the size small, a small size to get more surface area, how to use it in what application, they are well aware. So the techniques which they have used, we are finding it that it was more than the current advanced science which we are using today. That was the case.